Hi, this is a quick walkthrough of the question 8 on the June 2012 FP4 exam paper. Right, okay, so in this question we're given a point Q and we're also given the equation of this plane pi over here in the form of a dot product. Okay, and we're also given the line L and the equation of that line here. So this is our plane, this is the point Q, which we know, 746, and this is our line L over here. Now, the first thing we're told is that Q lies in this plane pi, so that means point Q must satisfy this equation here, and we want to show that this is true. Well, we know the point Q, and we know that if we dot any point with the normal, any point that lies on the plane with the normal, we should get 36. So straight away to answer part A, and I'll just pop that over here. To answer part A, we know that 746 dotted with 213 should give us 36. So 746 dotted with 213, and that gives us 14 plus 4 plus 18. And 14 plus 4 is 18, and 18 and 18 is 36. So we know that this is true. So we've shown that this is true over here. Right, part B. And for part B, we need to show that L is parallel to the plane pi. So we just need to think about this here, because we're given the normal to the plane. So in order for something to now be parallel to the plane, it must be perpendicular to this normal here. So we know the direction of L, because that's given by this part here, -753. So if that's the direction of this line L, and that turns out to be perpendicular to this normal over here, then L must be parallel to the plane pi. So what I'm going to do to show that they're perpendicular to each other, I'm going to dot them together. So I'm going to take -753, and I'm going to dot that with 213, and that gives me -14 plus 5 plus 9, which equals to 0. So because that's equal to 0, I can say that the normal to the plane is perpendicular to the line L, therefore parallel to the plane. Right. Okay, so that tells me that L has to be parallel to the plane. Right. Now, part C, the diagram shows that the point P. Right, before I start part C, I'm just going to clear up some room over here. So the diagram shows that the point P, which lies on the normal to pi, so this is point P over here, and that lies on the normal to pi. Second. And it passes through the normal that passes through Q, so we know that it lies on this line here, which is QP, and also the point R is on the point L, so this is point R, and this is on the line L, which is closest to P. So what we're looking for is we're looking for this point over here that's on the line L, that is closest to P. So the direction of P to R and the line L must be perpendicular to each other. In order for these to be closest together, these are going to have to be perpendicular to each other. We're also told that PQ, so the distance PQ is equal to the distance PR. And what we wanted to try and do is determine the coordinates of P. Right, so quite a lot going on here. So in order to work this out, the first thing we need to know is what the distance PQ is. Okay, so that's the first part that we're going to work on, the distance PQ. Now, we know the point Q is 746, so that's that point Q. So I also know the direction of this line QP, because it's normal to the plane, that's given by this over here. So I can say that P is going to be equal to, and we know that it goes through the point 746, so I'm going to start by saying 746, and P is going to be some multiple of 746 in the direction 213, so I'm going to plus lambda times 213. Okay, and I've used mu over here, so I can use lambda over here. Right, so now what I can do is I'm just going to say that the coordinates of point P are going to be equal to, and I'm just going to write this as a single vector as 7 plus 2 lambda, 4 plus lambda, and 6 plus 3 lambda. So this here now represents the coordinates of this point P over here, and I'm just gonna move this. Whoops! Just gonna move this over here. So we know that P is given by this over here. Okay, so that's the coordinates of our point P. Put that over there. Right, so our next job is to work out, well, we want to know this distance PQ. So that's what we're trying to find out, this distance PQ. Now, I know that to get from P to Q, well, it's in the direction 213, and I'm going to be, well, I've got a multiple of 213 that I've called lambda that's going to take me from P to Q, or Q to P. So my distance P to Q is going to be equal to, well, it's going to be 2 lambda squared plus lambda squared plus 3 lambda squared square rooted. Okay, so just to clarify why we've used that there is my direction, my general point was given by the fact that I knew where Q was, and then I've added on multiples of 213, and the multiple that I've added on is lambda. So it makes sense that using Pythagoras, the distance from here to here would be each of these squared and then square rooted. And I can simplify that to tell me that the magnitude of PQ, I'll just write it like that there, is going to be 4 lambda squared plus 9 lambda squared, which is going to be root 14 lambda squared, and I can just write this in a simpler way as lambda times by root 14. Right, so that's going to tell us this distance here, which is PQ. Right, I'll just tidy up a second. Right, okay, so my next job now is to find the direction of P to R, because I know that this direction needs to be perpendicular to this direction over here. So if I dot this direction with this direction here, I should get 0. So I know point P and I know point R, so to work out what again. So I want to know what P to R is, so I want to know what this direction here is, and in order to work that out, I'm going to take my point R, and I'm going to take away this point P over here. So point R here is given by this here, so I'm going to say that PR, and remember this is just the direction of this line, and that's going to be given by this here, which I'm going to write this as a single vector. So we've got 20 take away 7 mu, negative 8 plus 5 mu, and 1 plus 3 mu, and I'm going to take away this point P, which we know in terms of lambda. So that's going to be 7 plus 2 lambda, 4 plus lambda, and 6 plus 3 lambda. Okay, so that tells me that PR over here, and the direction of this line here is going to be, well, I need to simplify this over here, so that's going to be 20 take away 7, 13 take away 7 mu, take away 2 lambda, negative 8 take away 4 is negative 12, plus 5 mu, take away lambda, 1 take away 6 is negative 5, plus 3 mu, take away 3 lambda. Always worth double checking at this stage and making sure that you haven't made any errors, but I'm pretty sure I'm okay here now. Right, okay, so we now know what the direction of PR is. It looks a bit messy, but that's because this point here is given in terms of lambda, and this point here is given in terms of mu. So to get from this point here to this point here, we have to have something that's in terms of lambda and mu. Now, our next thing what we're looking for here is, because we need these to be perpendicular to each other in order to find the shortest distance, what we need to do is we need to dot it with the direction of this line here. Now remember, this line here is given by this, so this part of our equation of a line is telling us the direction of this here. So I need to dot this with this, and that will tell me and we need that to be equal to 0, and if it is, or we need to make that equal to 0, I should say, and if we do that, we're going to find the points that are going to make this perpendicular. So I've got a negative 7, 5, 3, and I'm going to dot that with this over here, which is 13 take away 7 mu, take away 2 lambda, negative 12 plus 5 mu, take away lambda, negative 5 plus 3 mu, take away 3 lambda. Right, so if I dot those together, and I want those to be equal to 0 for this to be perpendicular, I'm now going to expand this out. So we've got negative 7 times 13, which negative 91, negative 7 times negative 7 mu is plus 49 mu, plus 14 lambda, take away 60, plus 25 mu, take away 5 lambda, take away 15, plus 9 mu, oops, and take away 9 lambda. And we want that to be equal to 0, so just equating bits together, we've got negative 91, negative 151, and negative 166. 49 mu plus 25 mu is 74 mu, plus 9 mu is 83 mu. And our lambdas, we've got 14 lambda, take away 5 lambda, which is 9 lambda, take away 9 lambda, gives us 0 lambda. So the lambdas have cancelled each other out, so that's going to be equal to 0, which means 83 mu is equal to 166, and mu is equal to 2. Okay, and now I know that mu is equal to 2, I can rewrite PR because I know mu is 2, so I can write it in terms of lambda. So now PR is going to be equal to 13 take away 7 lots of 2, so 13 take away 14, which is negative 1 take away 2 lambda. Negative 12 plus 10 is negative 2 take away lambda, and negative 5 plus 6 is 1 take away 3 lambda. Right, so that's now how I get from this point here to this point here. So if I knew what lambda was, I'd be able to decide exactly how to get from here to here. Now, because I want this distance from P to Q to be equal to this distance from P to R, and I know this distance P to Q is given by lambda root 14, I need to equate that with this distance here that I now need to work out in terms of lambda. So I'm just going to tidy this up a little bit. Okay, so what we're saying here now is that what we're saying here now is that this distance, which is going to be given by the distance from P to R, and I would square root this, but this is going to be equal to the square of this over here, so it's going to be equal to 14 lambda squared. Okay, so the square of this distance is equal to the square of this distance here, is what we're saying. So if I now expand this out, so this expands out to be, it's just going to be the positive of this, isn't it? So it's going to be 4 lambda squared plus 4 lambda plus 1, which is that bit there, plus, and that's going to be lambda squared plus 4 lambda plus 4, and this here is going to be plus 9 lambda squared, take away 6 lambda plus 1 is equal to 14 lambda squared. Okay, and if I simplify this, I've got 5 lambda squared, 14 lambda squared, 4 lambda, 8, 2 lambda, so plus 2 lambda, 1, 5, 6 plus 6 is equal to 14 lambda squared. And these are going to cancel each other out, so I've got 2 lambda plus 6 is equal to 0, 2 lambda is equal to negative 6, and lambda is equal to negative 3. Right, well, okay, so now I know that lambda is equal to negative 3. So my final job now is, I know that the point P is given by this here, so P is going to be given by, so the point P, or the position vector of P, is going to be 7 plus 2 lambda, so 7 take away 6. I'll write it out. So we've got 7 take away 6, 4 take away 3, and we've got 6 take away 9. So the point P is going to be equal to 1, 1, and negative 3. So the coordinates of this point here is 1, 1, negative 3, and I could now work out the coordinates of point R as well if I wanted, and then I could check that this distance here was equal to this distance here, but that's going to be right. Okay, there you go. I hope you found that useful. Take care, and I'll see you next time.